Alright, here is my video guide for problem 5-144 in our chapter 5 closure. And what this problem is doing is having us work with our Pythagorean triples and notice Pythagorean triples in triangles to help us solve for missing sides quicker than just using the Pythagorean theorem. The two Pythagorean triples we've talked about in class, I'm going to write here, and I'm going to write one of them in this box, one of them in this box, and then I'm going to also write the variations of these Pythagorean triples. So the first one we had in class, the first one we talked about was the Pythagorean triple 3, 4, and 5, which means if you saw a triangle with legs 3 and 4, you knew the hypotenuse would be 5. If you saw a triangle with a leg of 4 and a hypotenuse of 5, you know the other leg would be 3, because this pattern exists. Variations to this pattern could be ones such as 6, 8, and 10, which is just your original 3, 4, 5, but everything got multiplied by 2. Another variation of this one could be 9, 12, and 15. So it's again your 3, 4, 5 triple, but everything got multiplied by 3. And I could do infinitely many variations to this, just multiplying it by different numbers. You could even multiply it by 1/2 or 10 or whatever it may be. The other Pythagorean triple that we've talked about in class was the triple 5, 12, 13. Again, meaning that if you saw a Pythagorean triple with legs 5 and 12, you would know the hypotenuse would be 13. Or maybe you would see a right triangle with one of the legs being 5 and the hypotenuse being 13. You would know that the last missing side would be 12 because this pattern in this triple exists. Variations to this pattern, again, it's just multiplying everything by a number, and you could choose any number. I'll just choose easy ones. So like multiplying them all by 2, you would get 10, 24, and 26. You would get 15, 36, 39. And so you can see, again, I'm just multiplying in this one, multiplying them all by 2, in this one, multiplying all by 3. And I could do that for really any number as long as I'm multiplying them all by the same number. Okay, so I'm going to erase these and these variations and then kind of show you how we use it to solve these triangles above. So if I'm looking at triangle A, I'm thinking to myself, is this one of the Pythagorean triples I know or a variation of one of the Pythagorean triples I know? What I notice is I have 12 and 15. 15 is my hypotenuse, 12 is one of my legs, and I'm thinking to myself, okay, well 5 times 3 gives me 15. And I'm also seeing that 4 times 3 gives me 12. And kind of following my Pythagorean triple, you see 5 is the hypotenuse, 4 is one of the legs. And remember, the triple that was here was 3, 4, and 5. So again, 5 was the hypotenuse. There's my 5. 4 was one of my legs. 4 was this leg. That means the other leg is going to be a variation of one of the 3's. And 3, and to keep it consistent, we got to multiply by 3 like we did here. So 3 times 3 would give you x equals 9 there. And so in part A, x equals 9. And again, it's based off the triple. It's based off the Pythagorean triple 3, 4, and 5. And it's the variation where all of them got multiplied by 3. And so the variation that we used here was 9, 12, and 15. Everything got multiplied by 3. Okay, let's take a look at B to see another example. Again, I'm looking to see, does it meet one of my Pythagorean triples? And what I notice here is I have a leg that's 10, a leg that's 24, and I'm missing the hypotenuse. And I see that 10, well, that is 5 times 2. 24 is 12 times 2. So again, same multiplier, times 2 both times. And I have 5 and I have 12. Well, one of my Pythagorean triples is 5, 12, 13, and so I know that my hypotenuse, my leg was 5 times 2, my other leg was 12 times 2, that means my hypotenuse is going to be 13 times 2 to keep the triple consistent, and that means my x here equals 26. So x equals 26. And that is, again, the triple. You can see it here. We had 5, 12, 13, so that was the triple that was being used. And it's the variation of that triple where everything's being multiplied by 2. So it's the variation 10, 24, and 26. So These are just two examples. You can see a lot of different examples because there's infinitely many variations to our Pythagorean triples, but always just look for variations of 5, 12, 13 and variations of 3, 4, 5. Every time you look at a triangle, like I did in A, say, can I see this as a variation of 3, 4, 5? I noticed the hypotenuse. Is this 5 times something? And is one of the legs, is this 4 times something? And just always look for these triples in these variations of them because they can help you solve them quicker. Never forget, though, that if you're struggling with Pythagorean triples, you can always just use the Pythagorean theorem and solve as well. It's not as quick. This is a shortcut. It's quicker. It'd be nice to get used to it, especially because Pythagorean triples come back around in later mathematics. But you can always use the Pythagorean theorem if you have to. Hopefully you find the video helpful. If you want more information on the Pythagorean triple, I can make a separate video other than this problem and try to explain it further.